It would cost SpaceX about $190,000 less to launch from Sri Lanka rather than Florida, because this region has the weakest gravity in the world. In school, we learned that objects fall at 9.8 meters per square second, but this is a global average. There's less gravity at the top of a mountain, and less at the equator where the spinning of the Earth stretches out the whole pudding. There's also more or less depending on the density of the rock. In reality, the gravitational field in Colombo is 9.7 meters per square second compared to another part of the world at Cape Canaveral, Florida. Gravitational field is 9.7 meters per square second where SpaceX launched the Falcon Heavy from. That means that if you drop weight from 100 meters in Sri Lanka, it will land 21.5 milliseconds later than if you do the same thing in Florida. Going the other way, the force of gravity acting on a rocket would be 0.215% less, meaning reduced fuel costs, theoretically. So why is gravity so low here? Was this an ancient spaceport? The best theoretical answer we could find is watery rocks. Earth's gravitational field is much lower than average in some places because of water-rich material that lies over the dehydrated remnants of long-subducted tectonic slabs. As a translation, we have watery rocks here, which are less dense, hence less gravity. This can be measured. Because sound waves travel faster through dense material, for example, water compared with air, the difference in speed with depth told the scientists that lighter, less dense material is lying over a layer of very dense material. Most likely, the top layer's relative buoyancy stems from its water-rich composition, the researchers contend. So how did this happen? How did our rocks get so damp? We've clumsily and incorrectly mashed up the plate boundaries with the gravity map. As you can see, the area of lowest gravity roughly corresponds to the Indian plate, which is one of the most interesting plates there is. It's the particular history of this plate, and how it shaped the rocks of the Indian subcontinent, that make this area especially light. Around 88 million years ago, the Indian plate started booking it north at 31 centimeters per year. This is the literal land speed record, the fastest that land has ever moved. It's now slowed to 5 centimeters per year. When that landmass hit Eurasia, it went under subduction. The Himalayas were then pushed up. All this while, tons of rock are being buried into the hot magma smoker under the Earth. This heat dehydrated the rock, releasing water, and making the crust more buoyant. Hence, because the Indian plate keeps smoking rock, the crust keeps getting hydrated and thus lighter. This has been happening for millions of years, enough time to give us measurably lower gravity. The Earth is visualized as a geoid, with higher points having more gravity, and lower points having less. What's it like? It means a person living in Sri Lanka will have 0.215% less weight than in the West, but given that it doesn't cost the person $90 million as it can cost SpaceX, it is possible that this marginal difference could, for example, be useful to a space elevator. Today we use this gravity information to help predict ocean currents or find oil and gas, but it conveys no particular advantages just being here. To a layperson like you or me, the Earth's gravity is just weird. If you like our content, don't forget to subscribe and